Section 11.2. This is on properties of power series. And we're talking about the radius of convergence and the interval of convergence. And if we go to example 1, it says the summation, this is part A, k approaches 0. From 0 to infinity, this is x to the k over k factorial. And they want us to find the interval and the radius of convergence. So we take the limit, I keep wanting to write an x, as k goes to infinity of, now what you're doing is the ratio test, and we can save a lot of paper if we just remember that it's the the k plus 1 term divided by the kth term. So I'm going to write this as multiplying by the reciprocal. So I'm going to write it as the limit of the absolute value. Then we're going to have x to the k plus 1 over k plus 1 factorial. And then we're going to put times, and I'm going to flip over the original. That saves the paper of having to write the division. And what can I cancel? I can cancel out the x to the k, and I can cancel that and leave an x. Now on the bottom, k plus 1 factorial is actually k plus 1 times k factorial. So I can wipe out the k factorials, and I will be left with the limit as k goes to infinity, 1 over k plus 1 absolute value of x. But as k goes to infinity, k plus 1 is getting larger and larger. 1 divided by a gigantic number is a tiny number, and so this is going to turn into 0. So since it's 0, that means the radius of convergence is infinity. Because remember in the ratio test, 0 is less than 1. So everything works. Anything that's going to be less than 1 means everything works. So if you get a 0, then the radius goes from negative infinity to infinity. The interval, negative infinity to infinity, the radius being infinity. R equals 0 means that all values of x work. Part B, summation k equals 0 to infinity, negative 1 to the k, x minus 2 to the k over 4 to the k. All right, for this one, we could use the absolute convergence using the root test. So using the root test, we take the limit as k goes to infinity of the kth root of negative 1 to the k, x minus 2 to the k over 4 to the k, which turns into the absolute value of x minus 2 over 4. And so if this to work, it's going to be convergent as long as that is less than 1, which means that the absolute value of x minus 2 is less than 4. Right there, once you get the absolute value symbol isolated, the number on the right-hand side of your inequality, that is your r. So in this case, we're going to say r is 4. And then if I try to solve this, it would be negative 4 less than x minus 2 less than 4. Adding 2 to all three sides, we get this. And so the interval in this case is going to be negative 2 to 6. This is the interval. Now, when you're using the root test, it doesn't tell you about the endpoints, so we need to check the endpoints on this. If we look at first looking at x equals negative 2, that summation would turn into negative 1 to the k, negative 2 minus 2 is negative 4 to the k over 4 to the k, which the negative 1 to the k and the negative in front of the 4 that's to the k are going to be a 1. This is going to turn into the sum of 1, which that'd be 1 plus 1 plus 1, that diverges. So I can't include negative 2. So let's check 6. If we check 6, the summation is going to be negative 1 to the k, I put a 6 in there, I get 4 to the k over 4 to the k. Those cancel, and so I am summing up negative 1 to the k, which alternates between 0 and 1, 0, 1, 0. Excuse me, no. Between 1 and negative 1, 1 and negative 1. So the sums are going to be between 0 and 1 and 0 and 1, which means this also diverges. So I cannot include the endpoints, so my interval is correct. The interval is negative 2 to 6, and the radius of convergence is 4. Part C, summation k equals 1 to infinity, k factorial x to the k. I think the ratio test would be good. The limit as, and ratio test is very easy to use when you have factorials. That's what makes it easy to use. So we're taking the limit as k approaches infinity. We're going to have the absolute value. We're going to have, oh, this is interesting. There's no denominators here. So k plus 1 factorial x to the k plus 1 over k factorial x to the k, which that's going to reduce. I can zap out x to the k and leave 1. And I can take out the k plus 1 factorial, make it k plus 1, and cancel the k factorial. So I'm left with, and I'm getting rid of the factorial there. I'm left with k plus 1 and an x. Well, as k goes to infinity, this is blowing up. It's going to infinity. So whenever you get infinity for an answer, then the radius is just 0. It's going to just land. That doesn't have any place where it's going to be working except for exactly at that single point where x equals 0. So this one has a radius of 0. There's no interval because it's just a single dot. It only works at x equals 0. That's the only place this series is going to converge. There. Okay, now we're going to talk about convergence of power series.